Okay, well, I thought I would just give you a real quick little video on this one. It's a Vizio GV47L FHDTV10A, and this one powers up. It's got the touchpad on the control on the front. Powers up, and then no backlight, no video, and it freezes and you can't shut it off. Much like the other video I did on the, I think it was a 32 or a 37 inch I've got up. So this one's going to be real quick, so let's do a quick troubleshooting steps. Okay, so the first thing you want to do is get your ohm meter. I have it in the tone or the beep mode. It still shows ohms, and we want to check the continuity of the 3 fuses on the main board here. So we want to see 0 ohms. And on this one we show that it's open. So let's talk about trying to figure out, is there a major problem with the main board, or is it just a defective fuse? So first thing I'm going to do is I'm going to put my meter in the current mode. I'm going to change my lead over to the amp mode, and I'm going to plug in the TV, and I'm going to turn it on, and then I want to measure the current. I'm going to put this in the min-max mode, and I'm just going to put this on the fuse just for a split second here, and then I'm going to go to min-max, and it's going to tell me it drew 1.117 amps of current, and the fuse is a 1.5 amp fuse, so that's within the current limitation. So let me take it out of the min-max range here, and I'll just go ahead and we'll just watch the current. So it draws about 1 amp. I'd say that's pretty normal. They probably could have designed the circuit with slightly larger fuse. Probably the inrush current as it powers up might do some damage to this little fuse. It's only a 1.5 amp fuse. So let's go ahead and replace this fuse and see how it goes. So here are the little fuses here. They're available through DigiKey, and there's their part number. If you have any questions, you can even call them. There's their phone number on there. So it's just soldered into place, so we have to basically heat up both ends and just get it unsoldered. Okay, so I'm going to just heat up each end of the fuse. May have to add just a little bit of fresh solder to it. Grab it with some pliers. If you can get both ends molten at the same time, it'll just lift off the board just like that. And just for practical purposes, I'm going to just clean off one pad. I'm just going to use a little bit of wick on it since that's readily available. So I want solder on one pad, but I don't want any on the other pad, so it'll make a good solid connection. And then we'll add solder, we'll flow it around the fuse. And it's probably going to be kind of hard to see on the camera, but I'm just going to take and physically place the fuse down here. I'm going to heat the bottom pad. It'll take the solder onto the fuse itself, and when I release it, it's just going to kind of hang there on one pad. So I'm just going to add solder to the pad here, and it'll wick itself up into the fuse. Then I'll add some fresh solder to the top side as well. Hopefully my hand wasn't in the way. Okay, and then there's our new fuse. It's hard to get a good view of it, but it's a 1 and a 1/2 amp fuse. There, you can read it, 1.5 amp fuse. Soldered into place here. There's the other two. One's a 3 amp and one's a 4 amp. But just make sure that, if I can get a good view of this fuse, that your solder makes it a good bridge from the pad up to the fuse itself. So let's fire up the set and see what we get. Alright, this is one of the touchpad models. So I should, there we get the blue screen. I don't have any signal connected to it, so I wouldn't expect to see anything at all. But let me just hit the menu. Let's see, with no signal connected, we may not get anything at all right now. Oh yeah, there we go. So I've got the menu up and going. The bar is the stand I have it standing in, so it's not a defect in the picture, but I would say that that would probably take care of it. So if this does not take care of it, then you should look at my other video, because this one does have these little regulators on the board. You can measure the voltage on these regulators. There's some over here in this area. There's a couple over here, as well as these larger higher current 3-terminal regulators. There's one here, there's one down here. So yeah, hopefully that'll get you pointed in the right direction. So odd enough, after I did this video on replacing the fuse, I got the set together and noticed the digital tuner did not work in it. And so as I was talking about at the close of the video, we talked about checking the voltage on these little 3-terminal voltage regulators, and I came across one right here, and you can see it's got about 3.3 volts on the input pin. However, the output pin has 1/10 of a volt, and I know that's way too low for any functions. The adjustment pin is 0 volts, and I did an ohm meter check to ground on the adjustment pin, and it's like 1 ohm, so it's effectively shorted to ground. So I do believe that this regulator IC should be outputting approximately 1.2 volts to the digital tuner, and it's not. So I'm going to go ahead and replace this little regulator IC, and we'll see if we can get 1.2 volts back up and get the digital tuner in operation again. So I'm just flooding the 3 pins with solder, as well as the tab, just to heat up the temperature of the body. Once it's all hot and molten, you can just push it out of the way. So I just sat the new IC on there. I tacked one lead down. I'm going to add a little bit of solder to the tab to get it molten. I'm going to add pressure while I'm heating the tab at the same time. And then I'll just solder the 3 leads. Okay, so here's the new regulator soldered into the board. Just look over the leads really good. Make sure that they're all nice and bright and shiny, and that they've got a good solid connection. This one does. Before you power it up, make sure there's no bridges, especially from the input to the output pin, because that could do some very serious damage to the unit. Okay, so I've got the new IC regulator in place now. 3.2 volts on the input pin. The adjust pin is ground, so we should have about 1.2, 1.25 on the output pin, because these have a 1.25 volt offset as explained in my other video. And we've got 1.2, so let me try to program up some digital channels now and see if our digital tuner is working at this point. And as on my last video, here is the part number. We got these from DigiKey. There's their phone number. You can look them up online to find the part numbers for the regulators. And I have it auto programming right now, and so far it's found 4 analog channels. And it says it found 6 digital channels so far, so it looks like things are going to go good. Looks like this is going to take care of the no digital tuner operation as well. So just remember, when you're checking these little voltage regulators, there are 2 types. There are fixed voltage regulators. Like on these, the adjust pin is grounded, which means it's fixed at 3.3 volts. This one right here, the adjust pin is ground, so the output is fixed at 1.8. You can see that if you look closely, the part number is a -18 here for 1.8. This one right here is fixed. Now this one is adjustable. It has 0.7 of a volt on the adjustment pin, which means the output is going to be 1.9 volts. Now to test it to see if it's a good regulator, you should have about 1.2 to 1.25 volts from the adjust pin to the output pin. I don't have any within the camera range, other ones that are adjustable. These are all fixed. And there, we're all set. There's a digital channel. It's working great on here. Let's try to switch over to another channel here. There's 12-2. That one's working absolutely perfect. Everything's great. Digital tuner's working, and I think we're back on the road on this one. Appreciate all your views, and hopefully we can keep more of this stuff out of the recycle bin or the trash, as the case may be. Thanks for watching.